Tonight, folks, we're looking for all the rational solutions to this radical equation. Now, I just want to point out Q stands for the rational numbers, but notice that 7 is a member of Q because it can be trivially expressed as a rational number. And again, I'm just stating the obvious, but just want to be sure. Sometimes people think this just means a pure fraction, but any integer also qualifies as a rational number. Okay. Now, it would be natural here to square both sides, but you quickly see you'll end up with a cubic. So if you squared this object over here, you would have 9x to the 4. So you would end up with a cubic equation, which actually has a formula, but it'd be better off if we looked at for another approach. Okay, it's the last one that actually has. I think Galois showed that once you got up to degree 5, you didn't have a formula that works like the quadratic. Now, so there's a pretty clear substitution here. If you'll notice, this object here is the square root of this object. So you can think of this as u squared, and this is u. And that's exactly what we're going to do right here. We're going to go ahead and make this fairly obvious substitution. We'll just go ahead and call u the square root of 3x squared plus 14x plus 116, excuse me. Now, notice that is, I don't know, I hate to use the word obvious, but if you just understand this relationship here, you have the square root of something, and then that's something, you have the square root squared. And so this, if this is u, then this is u squared over here, okay? So, and that's exactly the form, that's the actual structure of this original expression. It's in the form u is equal to u squared divided by 11. And after a little bit of arithmetic, you'll learn that u is equal to 0 or 11. You multiply, it's just very routine to get to here. So we get down to this state where u is equal to 0, u is equal to 11. And so all we have to do at this stage is just go back and remember our substitution. This right here would be for the case u equals to 11, right? And write that down, but anyway. Now, again, after you do the arithmetic, get everything on the same side, you get this statement right here. And you were told that you said find all rational solutions. Now, you could be nasty and there may not be any rational solutions. The answer may be there are none. But if we do have rational solutions, this expression, this left-hand side is going to have to factor. And so we'll look at the natural factorization. It has to look like something like this if it's going to have rational solutions. Okay, like this. And so what do we need here? We would need a plus 5 right here. Okay, plus 5 right here. And then a minus 1, and that's just mere trial and error. Okay, again, if you expand this object out, you have the product of these two linear factors is this quadratic expression directly above the left-hand side of the equation. And from here it follows very quickly that x is equal to 1/3, which is certainly a bona fide rational number, or x is equal to -5, which is a rational number because you can trivially think of it as -5/1. Okay, so we found two rational solutions. Okay, so there's two so far. It said find all rational solutions. So we still have to consider the case u equals 0, right? U equals 0. Remember, we got u equals 0, u equals 11 in this substitution form. And so when you do all of that, you end up with this, folks. And without going to too much trouble out here, you can just take a look at the discriminant. Notice that 14 squared, okay, remember famous discriminant here, b squared minus 4ac. So you have 14 squared minus 4 times 3 times 116. Now here's where the cliche lazy mathematician comes to bear. Who wants to do the arithmetic on this? But isn't it crystal clear that this is less than 0? So you see, this is what they call a discriminant, folks. This is D discriminant. Again, being lazy, that stands for discriminant. It's that object, it's the radicand in the quadratic formula result. And anytime you have a negative discriminant, that means that implies complex solutions. So there are indeed two more solutions, but they're complex, they're not rational. Okay, so that's two distinct complex solutions which we're not interested in. That we could have said just find all solutions and we would be interested in this, but we are just interested in the rational solutions. So x equal 1/3 and x equals -1/5 are the two rational solutions. And let's write it down right up here. X is equal to 1/3. And x is equal to -5. And again, not a hard problem, maybe a junior level problem at the Olympiad somewhere, but not particularly difficult once you spot the substitution. If you don't spot the substitution, it's a difficult problem. You'd have to solve a cubic, and I know I couldn't. I wouldn't want to take the time to do it. You could find the discriminant or something of it, but it's just, maybe it would work out, but I don't think things are going to cancel out nicely. I still think you would have a bona fide cubic, because you see this is 9x squared over here, and then this is 3x squared, and you multiply. So you see, 9x to the fourth. So you would have a non-vanishing leading coefficient. So you would have a bona fide cubic, not cubic, I should say quartic. Sorry, folks. Quartic, fourth degree equation, quartic. Okay, but in any event, it would be a pain. Cubic or quartic, it would be a pain to solve. The substitution is what makes the problem work out nicely. Good night.